Now we're to the final part of this hypertrophy series, and it's the part probably most of you wanted to skip to after watching about 5 minutes of part one. So let's get to it. This is the best practices for getting jacked. We're going to talk about lightweight versus heavyweight a little bit more. We're going to talk about should you train to failure, hypertrophy first, or strength first? What comes first? Best practices for the variables related to hypertrophy: intensity, volume, rest, type of contraction, contraction velocity, exercise order, and frequency. Lightweight versus heavyweight. By the way, who is that jack dude in that picture? But anyway, lightweight, 30 to 50%, is equal to heavyweight, 65 to 85, in the amount of hypertrophy that is that is created. Similar adaptations, the same number of high threshold motor units, high levels of mechanical tension, high level of active muscle fiber force, and then the maximum number of actin myosin cross bridges. All those things are happening. However, lightweight tends to be better for muscular endurance, heavyweight for absolute strength, which seems to make common sense, but yet there are people out there who try to debate that, which just makes no sense. So I would love for someone lifting 30 to 50% compete against someone I coach who's lifting heavy. They'll lose. All right. Heavyweight adaptations, increases in tendon stiffness. These are some of the adaptations that you're going to get from lifting heavy that you're not going to get from lifting lightweight to failure. So, increases in tendon stiffness, tighten, and collagen layers. So, tendon stiffness means that when the muscle contracts, the tendon won't lengthen. Otherwise, the muscle would contract and the tendon would then lengthen, and that would create a slower movement around the joint. So, improved passive force production and elasticity, which is great for athletes. Increases in the amount of lateral force transmission. 80% of force is transmitted laterally, possibly via costomeres, linking muscle fibers to the sarcolemma and onto the surrounding collagen layer, which is the endomysium, and eventually ending at the tendon, of course. So 20% of force is transmitted from sarcomere to sarcomere. 80% is transmitted laterally. Is what they're thinking is happening. So increases in activation of the muscles, meaning heavyweight activates the max number of muscle fibers for the entire set, whereas lightweight eventually activates all the muscles, but you get some at the beginning and some at the end, so they're not activated together. So increases in coordination happen when you go heavy. So that means less resistance from the antagonist. So you get used to going heavy. So then the antagonist tends to quit fighting you as much. Improved synchronization, meaning you're going to recruit those high threshold motor units quicker and at the same time, and you're going to that quicker means improved rate coding. That's the signal that you're going to get from the brain through the nerve to the muscle. So the alpha motor neuron to be exact. So lightweight adaptations, improved muscular endurance. So don't get me wrong, there's benefits of both. I'm just kind of biased because I coach powerlifters and weightlifters, which only care about mainly absolute strength, or in weightlifters' case, care about high force velocity at a high velocity. I mean, force production at a high velocity. So improved muscular endurance, changes in muscle fiber type, probably become more like a slow twitch fiber. Changes in muscular capillarity, that may be it. Increases in buffering capacity in terms of hydrogen ions, but that looks like that's probably not happening. But probably the most likely reason is increases in the rate of ion transport. And by that, I mean, you're talking about the sodium potassium pump. This whole process becomes more efficient, quicker. So, in resting muscle, sodium ions are maintained at low levels outside the cell. Potassium ions are maintained at higher levels inside the cell. So when the CNS sends a signal into the neuromuscular junction, it causes an electrical potential to propagate along the muscle fiber. So a sodium potassium pump is activated to reverse the process. So this seems to be the main reason for improved endurance from high rep, low weights. So possibly sarcoplasmic hypertrophy increases in mitochondria, glycogen, creatine, and sarcoplasmic reticulum, of which could improve the muscle fiber metabolically. So athletes that potentially benefit are CrossFit, wrestling, soccer, and cross country. Those athletes should spend some time doing the high rep thing. Should you train to failure? Uh, it depends, as always. So some things to consider before going out there and just getting a massive pump. And then at 85%, if you're lifting that heavy and above that, the weight is heavy enough to recruit the maximum number of motor units, and you're going to get the maximum number of active myosin cross bridges. So you don't really need to go to failure because you're already doing everything you need to do. So um, all that's going to do, if you take 85% and you go all the way to failure, it's just going to create a lot of muscle damage, and you're going to have to rest a lot. So things to consider. Muscle damage is caused from sustained excitation and induced influx of calcium ions under conditions of low energy status and hypoxia, so not enough oxygen. So muscle damage slows the process from deformed membranes, particular T tubules, leading to a disruption of calcium homeostasis. So, if there's not enough calcium present, then you're not going to be able to recruit those high threshold motor units because calcium is required to get those cross bridges kicking. Remember the myosin head has have to have enough calcium to for that all to happen. So fatigue can set in, causing an athlete's desire to train to drop, and this can increase the athlete's rate of perceived exertion. Meaning, if you that's why you do daily intent, whether it's subjective questionnaire or maybe a vertical leap or something else, whatever it is, or both. It's you do that because if there's more fatigue than you thought, or at the end, if you do we do a little on a scale from 1 to 20 times the time. But if it's a lot higher than I thought it was going to be, then I know that my intent is not being met, and so I need to make changes to meet the athlete where they are. Like right now, exam time. These guys are going to be getting killed. They're probably not going to be as strong or as fast as normal because of fatigue. So the amount of damage will determine the frequency of sessions. Training during high amounts of damage is a waste of time with no hypertrophy taking place and potentially more damage. It's a good way of getting injured too. That's why during exam time, the injury rate goes through the roof. So let's chill with that. Um, GymAware RS and the flex units to the rescue, and here's why. If 85% intensity is automatically slow enough to produce the hypertrophy that you're after, that means 0.45 meters per second is a solid velocity for hypertrophy. Failure happens for most athletes around zero point 0.3. We talked a lot about this in part two, but we'll review in the squat, and 0.18 for strength athletes like powerlifters, like my man Tank. I think he can go to 0.15, which is slower than I could ever go. But um, velocity and velocity loss are the keys. So if I start at zero point 0.5, then there's no need, to go much lower than 0.45 meters per second because I am getting hypertrophy in all those reps. So, and if I'm pushing as hard as I can, I'm getting all kinds of good adaptations that are going to come for strength athletes. So if I'm lifting 70%, I'm probably around zero point 0.7 in the first rep. So it requires around 30% to get to hypertrophy velocity, around this zero point 0.5, 0.45 meters per second. So, the whole thing with the velocity loss, like it will always depend. You can't say 60%, is in just universally because if I'm at 85% and I'm at 0.45, I can't get to 60%. So you need to take into consideration what is the first rep, how fast is it? So we spend most of our time around 80%. That's what I do with most of my athletes because I'm trying to get them strong and explosive. Therefore, very little velocity loss is required. And normally, what we do is we limit it to 20% maximum. And because we're at 85%, I mean, we limit things to 20% velocity loss at a maximum of 85% of the time. So once in a while, we'll go to failure. because I do want hypertrophy. It's just that the majority of what I'm after is force production at a high velocity. That's what weightlifting is. That's what power. If you coach football, baseball, basketball, that's what you're after. Oh, by the way, let me go back. Here's a little chart that you guys can look through, and it's just like this is mainly for squatting, but this gives you an idea. Say like at 80% should be around 0.5, 77, 0.55, 75.6. Now this does not match up with bench press, obviously, because you have less distance to create force, so you have less time to create force. So impulse equals force times time. I have less time. That means I create less velocity if you understand the relationship between impulse and momentum. So um, moving on. Variables to consider. Strength is required first, and here's why. To recruit the maximum amount of high threshold motor units, a heavy weight is required. And so, like, when someone first starts, they're not strong enough to recruit those high threshold motor units. However, they get a lot of neural adaptations for strength first because they're going to get more coordinated. Their technique is going to get better. That's why you get the newbie gains you hear us talk about. So, two ways I use GymAware to monitor that: we look at bar path and we look at moving a particular load at a higher rate. So, instead of like me trying to go heavier and heavier and heavier, yeah, I can pick whatever load that I want. If that athlete starts moving that particular load faster, then especially in the first few months of them training, they've gotten better at their technique and they're getting better with intermuscular coordination, meaning their antagonist agonist are working together instead of against each other. And I can look at bar path. If it's let's say that they're doing a clean, and if the bar moves forward off the floor, then I know it's not necessarily they're weak. I got to teach them to sweep the bar in closer to the bodies. Or if it, once they extend at the top, if the bar flies out in front of them, I got to teach them ways to keep the bar in tight and to that will if you think about moment arm, if I keep the bar closer to me, the center mass will be in more of my advantage, aka mechanical advantage. So variables to consider for getting jacked. Now these are three very different athletes. This is a powerlifter. That's me, of course. This is Johnny Jackson, a bodybuilder. He did some powerlifting too, but here's my point. This guy competed against me in powerlifting, and like you would think that he was going to whip me because I mean he's huge. He looks like the Hulk, looks bigger than the Hulk. But I won because of my training. He probably spends more time doing the lighter weights for high reps, so he gets jacked. But his he does not have the intermuscular coordination. He doesn't have the synchronization of the high threshold motor units firing at the same time and at such a high rate as I do. So, but then again, there's Ryan, who's like doesn't look near as big as. I mean, he's obviously very muscular, but yet that guy can lift similar weights as us because it's, especially when you think about um, heavy weights at a high velocity, he's going to beat us. That he is clean and jerked more weight than I did, and I was a 91 kilo lifter, so I was 200 pounds. He's 160 pounds, aka 73 kilograms, and he's clean and jerked more than me. So he can move massive amounts of force at very high rates of velocity. Um, so this was little explanation of these three athletes will set me up for how all of these variables can be used to tailor programs to create the type of hypertrophy that you're after, depending on your own goals. Intensity. You can use anywhere between 30 to 85%. 30 to 60% is that low load. That's the low weight, high reps. Whereas 61 to 85% is the typical, high load, moderate repetition. And the key is the number of sets to near failure. Because what we've found and what the literature is telling us is that about five total reps can be to the can be used towards maximizing hypertrophy. Anything beyond that, and because at that velocity, you've gone so heavy or you've become so fatigued that the bar is somewhere around 0.45 meters per second. You can maintain about 5 reps before you're going to be at near failure. Um, so thinking about those 5 reps at those slower reps. So whether you're doing 15 or whether you're doing 5 sets of 15 at the low reps or 5 by 5 at the heavyweight, you're going to get the same amount of 5 reps per set. That's going to count towards hypertrophy. So um, let's talk about volume. 5 to 10 sets of near failure reps per body part. 5 reps are maximized. I already told you the 5 reps are maximized for hypertrophy. The velocity of the reps must reach sub 0.56 meters per second to be slow enough for maximum cross bridges in those and to recruit those high threshold motor units. So if I'm Johnny O. Jackson, then I can do whichever one I want, and I would probably recommend spending quality time at both. As we explained in part 2, there's a good chance that this type of hypertrophy might create more sarcoplasmic. We don't know that to be a fact, but it might create more sarcoplasmic hypertrophy, which is the non-contractile, and this might create more contractile, the myofibril hypertrophy. So spending quality time at both is going to maximize this gigantic guy over here. Whereas a powerlifter wants to spend the majority of his time here, close to the 85% mark, but yet a weightlifter like Ryan probably wants to be somewhere around 60 to 70% a lot of the time so he can move fast enough to create maximum power. So now, but let me say one thing before it goes forward is that just focusing on power is an arbitrary variable in nature. Meaning, if I only care about where do I create the most power? Oh, it's 60%. Well, I'm going to do all of my reps there. Well, that doesn't necessarily mean you're getting better at producing power. You're just picking the number that creates the most power at that workout. What you need to find out is do I need to get more force production or do I need to get more velocity to maximize my power? So, anyway, hope that made sense. Rest intervals, it appears that 2 to 3 minutes is optimal between sets. Less rest will minimize volume and effort and create more fatigue, and then more rest showed no benefits. So you're just wasting your time spending time in the gym where you could go home and rest. Types of contractions. Eccentric. That's the lengthening. I always use RDLs because I guess I've been so sore from those things. It's easy for me to see those as an eccentric movement. But accentuating the eccentric contraction, and by that, just doing RDLs is not going to necessarily create the adaptations I'm talking about here. But if you really want to accentuate this, what you're about to learn, it's like adding weight releasers or putting the heavy weight on the back, lowering it, so when taking the weight off, you standing up with a lighter, or just lowering it, leaving it on the rack, getting people to help you put it back up. But eccentric, you're capable of about 120 to 130% more overall force in the eccentric contraction than in the concentric, due to the elements in the body that resist stretch, like tighten, nebulin, and the connective tissue. So activates the P70 S6K and the RPS6 elements in the mTOR anabolic pathway greater than the isometric or the concentric contractions. Type 2 fiber hypertrophy is maximized with eccentric contractions, tighten tendons, and connective tissue are all created stronger and thicker, aka they're all growing. Concentric on the other hand, contribution of nuclei to myofibers possibly by satellite cells and the response of interleukin 6, IL-6, which is associated with satellite cell signaling. Even amounts of hypertrophy have been found between eccentric and concentric as far as total circumference of the muscle. However, as you can see, They're number one. They're probably using different pathways. I say probably because let me be clear: is that there's still more research needed in the world of hypertrophy. It's just very hard to like take a human and like cut the cut their leg open and watch their legs grow. So it's a delicate process and it's going to take a little bit longer. But what we're seeing is that there's equal growth. However, that growth is not all the same. Meaning, not all hypertrophy is created equal. Um, Isometric, more hypertrophy with isometric contractions at long muscle length versus short muscle length. Also strengthens connective tissue. So regional hypertrophy, I think I mentioned that in the very first episode. Andy Galpin talked about it, where when a muscle grows, it doesn't grow evenly. So your vastus medialis, when it gets bigger, it doesn't get bigger equally all throughout. Maybe it's going to get more distal or more proximal, more medial growth, um, for who knows why. But with the isometrics, I will say this: if you're doing, say, a squat, an isometric squat in the fully lengthened position, the hip extensor that's going to be maximized is going to be the adductor magnus. However, if I do an isometric towards the top of the squat, it's going to be the gluteus maximus. It's just because it depends on the where the force is maximized and what the body has to overcome. That's going to be determining of what muscle it recruits. So. Um, Let's see, did I get all that? Oh, joint angle dependent. I already said all that. So, dynamic repetitions, concentric and eccentric are better for maximum hypertrophy. Meaning, do both if you want maximum hypertrophy. So, do it regular squats. So, don't just do eccentric and don't just do concentric. You know, you split up the contraction when you're after something else, meaning you're after, like if I'm doing eccentrics, I'm trying to get more elastic, I'm trying to increase, stiffness in my tendons, and I'm trying to get the type 2 fibers. So isometrics to target joint angles and specific weaknesses. Nothing beats it. So, you know, use concentric and eccentric for getting maximally jacked. Use isometrics to target weaknesses. Okay, the velocity of the repetition. Here's one that's going to probably throw you for a loop, but maximizing an athlete's eccentric contraction velocity is shown to maximize the hypertrophy of type 2 fibers due to, once again, overloading elements, resisting stretch, tighten, collagen. Um, Maximize the velocity of each repetition as it relates to the load being lifted for maximal hypertrophy. We've already said that. If you want to get jacked, lift it as fast with as maximum effort as possible. So, for best results, perform a force velocity profile like you see over here. Um, just looking at this is probably not a squat because at 100% it's 0.36. I'm probably guessing that is let's see, 7% 0.61. That's probably either a bench press or a military press. I'm just guessing though, but what you're going to do is you'll do the different movements that are important to you that you plan on, one, trying to get stronger at, two, that you feel is going to give you the maximum amount of hypertrophy. Do the velocity profile, and then instead of like saying, hey, do 70% for 5x5, tell them to work up to 0.61 meters per second for 5 reps and then stay there for 5 sets. So, and then you can like make sure that they're staying somewhere between the range, and you're only dropping 20%, or 30%. I guess if you're starting at 0.61, if you get a 30%, that's 0.18. Yeah, that's going to be perfect. So, but now if you're at 0.48, you're doing 80%, 15 to 20% is maximized, is the maximal amount of velocity loss you're after, unless you're just trying to do maximum hypertrophy for whatever reason. So, um, for best result, considering the starting load as it relates to velocity loss, 40 to 60% velocity loss for maximum hypertrophy, 20 to 30% when power is a concern. That's assuming that you're starting probably anywhere from 70% and down. If you're 75%, you're already at 0.53. You don't have very far to go before you're maximizing it. So, and we've already said that at 85%, you're already there. So, that 40, 60% is mainly you're talking about that 60, 70% that most of us think about when we're doing eights and tens. So, exercise order, movements of greater importance first. So, if you're a powerlifter, squat goes first. Multi joint before single joint. The faster movements, the more technical movements, you want to put that first before all of these. Because if you don't want to do a snatch or a clean fatigued, because that will mean you'll have less use of the brain to actually perform good movements and technical work. So frequency. Total volume is more important than frequency. If you can get 10 sets of 5 really good reps at any given body part, then you could just do it once. However, it's really tough to get 10 sets of 5 hard reps in a body part without getting so fatigued that you're probably not getting a whole lot of good results. It's much easier to go really hard, say for 5 sets of some good repetitions, rest for a couple of days, and do it again. So it's better too if strength is your concern. It's definitely important because you want to get better at your craft and get those neurological improvements in strength. So um, max four hypertrophy is maximized at 10 total sets. Max force, velocity, and high threshold motor unit recruitment requires minimal muscle damage and fatigue. So probably better to split body parts up over a couple of days. Technique is as to be a concern for strength athletes requiring more frequency. And then 2 days is probably best because it still allows for enough rest between days to repair muscle damage. And honestly, I'm really considering mainly weightlifting coaches and weightlifters are used to squatting a minimum of 3 days per week. But I'm considering, especially with guys like Ryan, to go to only 2 because the focus is snatch and clean and jerk. So do I really need? The research is pretty clear that I can get the maximum amount of hypertrophy from just 2 days. So that's something I'm going to make a change in rather soon. Um, Variety too. Oh, by the way, here's a little chart. This was from Arantes et al. This is actually the study that Dr. Cook from the North University he helped with this study, and it's a really good one. So if you want to look this up, it lays out hypertrophy in such a clear, precise way. Also goes over is it the hormonal response or is it the mechanical tension that's important to hypertrophy? And it was very conclusive that yes, it's mainly just mechanical. The acute hormonal spike that you get probably has very little to do with hypertrophy, actually. So variety as a bonus. Remember, Dr. Galpin showed us clearly that hypertrophy happens regionally. A variety of movements might help to smooth it out. A little goes a long ways. Example: using bands for squats. That will help you hit the glutes more than the adductor magnus, like I said earlier, because now the maximum amount of force to overcome is at the top versus the bottom. So examples of variety would be adding bands or chains, add accessory work, alter the range of motion, and then of course, yeah, there's use a different exercise. I just wouldn't get as crazy as Louis Simmons might have thought. The conjugate method maybe took it a little too far because you do have to, if you're a strength athlete especially, you do have to get better at, you still need to get really good at your movement, even if it's squats. And to a lot of you maybe think, oh, squatting is so easy. Do I really need to practice it? You do, if you want to become great at it. And if I'm a football coach or basketball, whatever, I probably want my athletes using whatever it is often. So if you use a safety squat bar, use that as your primary way of squatting because as soon as you squat, use a different apparatus to squat with, there's time that's going to be required to become efficient at that because now the body has to adjust. So it's better, specificity will always reign supreme. Remember that. Takeaways. Sets of a heavy 5 repetitions is best for maximizing strength and hypertrophy. 30 to 60% is great for maximum repetitions, which will maximize hypertrophy and muscular endurance. Heavy sets, around 80 to 85% for 5 repetitions, getting close but not actually reaching failure, are best for maximizing hypertrophy, strength, and training frequency. I would say 70 to 85% instead of just 80 to 85. But change up exercise variations and movements to ensure symmetrical growth, but it's not as crazy as maybe Westside Barbell would have once thought. So you don't have to just completely get rid of your barbell and use a totally different bar, but you can. So 10 total sets per body part. Maximize the velocity on each rep, both eccentrically and concentrically, if type 2 fibers is of importance. But I'm not saying, let me be clear, I'm not saying that you want to go as fast as you can out of control. I'm just saying go as fast as you can during the eccentric contraction under control. And that is why bands are probably going to be a little bit better, because they're going to speed up that eccentric contraction, or using weight releasers or the flywheel. So dynamic repetitions consisting of a concentric and eccentric contraction are best. Isometrics are better for hypertrophy and strength at a specific joint angle. A frequency of 2 to 3 times per week for a total of 10 sets per body part might help to maximize effort and repetition velocity to ensure maximum hypertrophy. So a rest interval of 2 to 3 minutes, and place the multi-joint higher velocity and the most important movements first in the exercise order. Conclusion. Use GymAware or RS or the flex units to make sure you're in the proper velocity zone that you're after. Hence, it's good to do the force velocity profile, and to ensure the velocity loss is appropriate for your individual goals, and to assure compensatory acceleration is actually happening. I doubt many of you are actually doing compensatory acceleration as often as you think. So bar path and other neural adaptations are seen quite clearly by using either the flex or the GymAware. And you can analyze it later on too by looking at the bar path as it relates to position. They line up really well. So if you go back, sorry, I know you guys, I'm long-winded, but yeah, as you can see here, you can see the position with the bar path, and you can see how if these things are lining up. So now back to this. For any questions, email me as always at travis@gymaware.com and ask me if there's a topic that you want me to really do a deep dive on and lay it out for you nice and crisply like I've been. Email me those questions or those topics at travis@gymaware.com. I really appreciate you guys, and just a shout out to GymAware for allowing me to do the thing I love. It is a dream job, and I appreciate you guys for giving me this opportunity. My family thanks you as well. Once again, here are some of the references. Believe it or not, we've added, every time I've created a new slide, these references have gotten longer and longer and longer. So if you want to look through them and read through all this like I have, feel free. Once again, thank you, and I'll see you next time.